Okay, so we're going to cover systems of equations today. There are three ways to solve systems of equations. There's elimination, substitution, and graphing. Graphing, I will show you, but not in the extent of, I'll describe it to you. I'm not actually going to show you how to graph because at this point you guys know how to graph, but I will kind of describe it and then I will verify the solution using one of the other methods. So when we're talking about elimination, this is what we have to do. We have to look at the two equations that they give us and we have to figure out, okay, which variable would be easier to eliminate, the x or the y? In this case, you'd have to multiply you'd have to multiply the equations by the opposite factor anyway. So what I would look at is the fact that here they want you to find the value of y. So I'm going to choose to eliminate x. So in this case, I will multiply the top equation by 6. Now, the rule in general convention is to multiply so you can get the lowest common multiple. I find sometimes students kind of get stuck and struggle on finding the lowest common multiple. So if you just kind of go with this technique, even though you may end up working with a little bit bigger of numbers, or you might be able to see that you can divide some numbers out and kind of, find a common factor within your equation, this approach will always work for you and it probably will make you less frustrated. So we're going to multiply everything in the top equation by 6. 6 times 7 will give us a 42x. 6 times -2 will give us a -12y. And then 6 times -31 gives us a -186. Here you can see that's a little bit bigger of a number than you probably like to deal with, but it's going to be okay. All right, so what we're going to multiply the second equation by is a -7, because what you want to pay attention to is that both of these have the same sign. So you want to end up changing one of the signs. So we're going to change the bottom sign by multiplying by a -7. Okay, so here we get a -42x, a -35y, and a -49. Now, what we'll notice here is that the 42x's will cancel. That's leaving us with just the y's. So -12 and -35 will give us a -47y. And then if we combine our constants on the right, we get -186 plus a -49 will give us a -235. If we divide by -47 on both sides, then we're looking at y is equal to 5. If you needed to know the x, or if you wanted to know the x, you then would just plug the y in for either equation 1 or 2, solve, and you would get the x. But in this case, they just wanted a 5, or sorry, they didn't want a 5, they wanted a y. So there it is. Right, let's keep rolling. So number 2. Number 2, we're going to actually solve number 2 by using substitution. It doesn't tell us what we have to use, so I'm going to show you on the next one, like describe the graphing to you, but instead, so for this one, we'll use substitution. So what I chose to do is I wanted to solve equation 1, so the top one. I wanted to solve it for x. Okay, so we have 5x minus 3y equals -7. We're going to add 3y to both sides. So we'll have 5x equals 3y minus 7. Finish it out by dividing by 5. So that looks a little weird, but it's going to work out for us. So now that we know what x equals, we're going to plug x into the other equation. So 15 rather, and it would be times x, but we're going to take this and plug it in for x. So it's going to be 15 times 3y minus 7 all over 5 minus 9y equals -21. The 5 and the 15 are going to cancel, and we get 3. So 3 times 3y will give us 9y minus 21. Oh, sorry, not 21, 27. Apologies. I knew something didn't look great. No, it is 21. 21, right? Minus 9y equals -21. Now, what you're going to notice is that 9y minus 9y will cancel and give us 0. But if we add 21 to both sides, then those also cancel. So we're left with 0 equals 0. So what you want to ask yourself is, what kind of statement is 0 equals 0? That would be a true statement. And since it's a true statement, what that means is if we rearrange that, those two equations, you would actually get this same equation, which means this sits on the same line, which you can kind of tell, because if you multiply the first equation by 3, you get the same exact second equation. So this is the same line. So it would be your answer here, and your truest answer would be all real solutions. And I mean, most professors would, as long as you tell them that that's the same line, they're going to understand and accept, that you know what you're doing there. Okay. So if you have a true statement, it can be 0 equals 0. It could be that -21 equals -21, whatever it is. That is a true statement. Like, obviously we can't have -15 equal to -21. Those are two different statements. So we would want to say that they are the same line. Okay. This is another special case. You don't know that yet, but you will know that. So what I would do here, if I wanted to graph this, I want to solve both for y. So the first one's easy to do. So y equals 2x minus 16. And then the next thing we're going to do is we're going to solve for y for the second one. So that would be -2y equals -4x. I went ahead and just moved it, plus 30. We're going to divide both sides by -2. So our other equation would be y equals 2x minus 15. So if you graph this, what I want you to pay attention to is look at your slopes. You have 2x and 2x, but then your y-intercepts are off from each other. That means these lines are going to be parallel. And so if you graph this, you would see that they would never ever cross. The second approach I can show you is we can now set the y's equal to each other to prove that these are in fact parallel lines. So 2x minus 16 equals 2x minus 15. And we can set these equal to each other because if you think about it, y equals y, right? So what happens is we subtract 2x on both sides. Our x's cancel. We're gonna add 16 to both sides. We end up with a statement of 0 equals 1, and we know that is incorrect. That is false. It's a false statement. So if you have two equations and we get a false statement, then you're talking about two perpendicular lines, which means they're never going to have a solution. Okay. All right, so that is it for two equation systems. I am going to show you at least one. I'm actually going to show you two. So I'm going to show you a special case. Let me go to the special case first. It'll be a little bit quicker. So what we're going to do here is the first thing we'll do is we're going to eliminate z. Okay, so to eliminate z, we're going to look at how to do that. So right here we have a 3z on top. So if I want to multiply the top equation to get a 6, I'm going to multiply everything on top by a 2. And you can always pause the videos to write down the problems yourselves. So 2 times 5 will give us 10x minus 8y plus 6z equals -8. Here's what I want you to pay attention to. Look what happens when we now bring over the second equation. We didn't just eliminate z, we eliminated everything. Okay, so that would be 0 equals 0. And that, of course, is a true statement, but are both sets true statements? So let's check this one. If we want to get to a 9z, we would have to multiply the top equation by 3. Actually, -3, right? Because we want to be able to cancel it out. So we're going to take -3 times 5x minus 4y plus 3z equals -4. We're going to bring that here. It's going to be -15x plus 12y minus 9z equals 12. And what do you notice? Again, if we rewrite this, bring it over here, we rewrite 15x minus 12y plus 9z equals -12. Again, we have 0 equals 0, true statement. So this means there will be infinitely many solutions. Okay. Infinitely many. All right. I don't want to take up too much more of your time, so I am going to do one more. And then that way, if you guys need help, there will be another one that we can work on together. So let's look at eliminating. Let's eliminate the x's. Okay, in this case, because we just did z's, right? So let's eliminate the x's. You want to look at 2 of the equations first and then the other 2 to try and help you. Now, typically what I would tell students is look for the ones with coefficients of 1 Actually, you know what? Let's do that. Let's get rid of the y's. Let's eliminate the y's. So I'm going to use equation 3 as my base equation. And I want to multiply equation 3 by a negative 3, so I can eliminate the 3y in the first equation. So I'm going to rewrite this one: 4x minus 3y plus 2z equals negative 29. Okay, and then I'm going to multiply this one, equation 3, by a negative 3. So negative 3 times negative 8 will give us a what is that? 16, 20, 24. So positive 24x. Positive 3y minus 9z. And I did this a little bit differently for you guys than I did on my scratch papers. Let me get my calculator out for it. 23 and negative 3 will give us negative 69. I should have remembered that from basic math. Okay, so the y's cancel, and we get 28x minus 7z equals negative 29 plus negative 69 is negative 98. Okay, so that is one of our new equations, and you can call it equation 4, you can call it equation A, whatever you want to call it, but that's one of the ones that we're now going to concentrate on because now we have 2 variables left. Okay, so now we have to use equation 3, and we're going to multiply it by a 2. Okay, so 2 times, just going to throw that here, 2 times negative 8 will give us a negative 16x minus 2y minus 2z. Nope, I was looking up at the top. My apologies. Looking at the one. Minus 2y plus 6z, there we go, equals 46. Okay, now I'm going to bring down equation 2. So that's 6x plus 2y minus z equals negative 16. Y's cancel. We're left with negative 10x plus 5z equals 30. Now, if you take a minute, you can see that actually we could reduce this a little bit. 5 goes into each of the bottom ones, so you would end up with, if we divide by 5 here, divide by 5 here, and divide by 5 here, we end up with negative 2x plus z equals 6, and that's a little bit nicer of an equation. And the other one, let's see if 98 can be divided by 7, and it can. So you would have 4x minus z equals negative 14. Well, hey, look at that. We can do another elimination. The z's cancel. So let's just do that. That's nice. Get rid of those z's. You get 2x equals negative 8. Divide both sides by 2. So we get x equals negative 4. Sorry, I dropped the negative on my paper. I wanted to make sure I write it down. So x equals negative 4. Now that we have x, we can plug x in and get z. So negative 4 times 4 will give us a negative 16. So right here, negative 16. We're going to add 16 to both sides. So z is going to be negative 2. Yeah, z is going to be -2. So then that leaves us with, we now have to find y. So if you go back to the top, 4 times -4 will give you a -16 again. 2 times -2 will give us a -4. If we add those together, that's -20. So we have to add 20 to the right. So that'll give us -9 left. -9 divided by a -3 will give us 3. So your overall answer here is -4, 3, -2. You want it to go in alphabetical order. Oops. So -4, 3, and -2. Very good. All right, so that is system of equations. If you have any questions, feel free to email me. Otherwise, finish up to your 90 and do your math retake. All right, congratulations, guys. Have a good day. Bye.